And today we're going to be talking about dividing polynomials. Dividing polynomials. And dividing polynomials is important because it can help you find factors, especially when you start trying to find solutions or roots or zeros of polynomials that have the higher degrees and all of the methods that you know won't work. Sometimes you can use division of polynomials to help you find at least one factor, and that can help you get started. And when you're working with dividing polynomials, the remainder theorem is important to be aware of. Remainder theorem. And it says when you divide polynomials, and the remainder is 0, then the divisor and quotient are factors of the dividend. So if you remember how to factor old school, like back when you were in 3rd grade probably, you learned how to use long division of factoring. Some of you may have learned the new math way, but when you divide polynomials, you do the old math way. So if you remember that, it's going to help you with polynomials because it's the same process. We just have variables and exponents thrown in the mix instead of just numbers. But let me remind you the old school way first so you can kind of remember the pattern. If I had 8 over 2, that's a fraction. Which fraction is division? That's technically a halves, or the fraction bar is a division symbol, right? It means 8 divided by 2. So we know the answer is 4. But I'm going to do it using long division, okay? So under the division sign, we would put what's in the numerator, right? 8. And whatever is under the division sign is called the dividend. Whatever we're dividing by, the denominator, goes on the outside of the fraction symbol, and it is called the divisor. And whatever our answer is goes up top, and it's called the quotient. And of course, we may have a remainder, we may not have a remainder. So, when you divide, you say 2 times what is 8? Or 2 goes into 8 how many times? 4, right? Is 2 times 4 8? Okay, so however you want to think about it, you're finding the same number. So however many times 2 goes into 8, that number we're going to put above the 8. And then what do? Multiply. We say 4 times 2 is 8. We put it here. And we just subtract, but when we do polynomials, I like to use one of my little phrases to help you remember. And my little phrase is, we draw a line and we change the sign. We subtract. So what's 8 divided by 8? 0. Is there anything left to bring down? No. So my remainder is 0, okay? My quotient is just 4. So, since my remainder is 0, that tells me something about my divisor and my quotient. According to the remainder theorem that we just wrote in blue above, what are 2 and 4 factors of 8? Yeah. What's 2 times 4? 8. So they're factors of 8, right? So whenever your remainder is 0, you know that the divisor and the quotient are factors of the dividend. Okay? They can be multiplied together, and you'll end up with a dividend, which that's important when you're doing polynomials. Okay? So let me show you one where we may not have a, or where we may have a remainder. 15 fourths, or 15 divided by 4. So long division, 15 would be my dividend, 4 would be my divisor. Can 4 go into 1? Can 4 go into 15? How many times? 3 times. Any more? No. So we'll put a 3. We'll line that up with 5. 4 times 3 is 12. Then we draw a line and change the sign. So 15 minus 12 is 3. Is there anything else to bring down? No. If we wanted to turn this into a decimal, we could put a decimal, zeros, and bring them down, right? But we're not doing decimals. I just want to see if we have a remainder. We do have a remainder of 3. So are 4 and 3 factors of 15? No. Now 3 is a factor of 15. But together, multiplied together, they're not going to give me 15. And just by knowing that the remainder is not 0, I know that they're not going to be factors of 15. Okay? So the way you might see this answer written, you may see the answer written as 3 remainder 3, or as a fraction. And when we do this with polynomials, you can see it written either way. So remember, if you're going to write it as a fraction, 4 went to 15 3 whole times, with the remainder of 3, that always goes in the numerator of the little fraction you're going to create, and the divisor always goes in the denominator. And that's good to help you remember, because a lot of people still can't remember how to turn an improper fraction into a mixed number, right? It's all about division. 4 goes into 15 3 whole times, 3 left over, and the denominator is always the denominator. Or if you want to call it the divisor.
3 3/4.
3 and 3/4. Or 3 remainder 3. You're going to see it written either way, right? So now let me show you why we're doing long division, because now we're going to do it with polynomial. Directions say, use polynomial long division to divide 4x squared plus 23x minus 16 by x plus 5. What is the quotient and the remainder? Okay, so we're dividing 4x squared plus 23x minus 16 by x plus 5. So x plus 5 is our divisor, and 4x squared plus 23x minus 16 is our dividend. So the one thing you do have to remember, not the one thing you have to remember, but one important thing you have to remember before you get started when you're using long division, you have to look at your divisor and your dividend and seeing if you're missing any terms, okay? So my divisor, I start with 1 degree. So I need to make sure I have a term with 1 degree and a term with 0 degrees. If I don't, I put a placeholder in of 0, okay? So 1, 0, I'm good on the divisor. In the dividend, I started with 2 degrees. So I need a 2 degree, a 1 degree, a 0 degree. If I'm skipping anything, I just put in a 0, or a 0x squared, because that means the same thing as 0, or a 0x cubed, because that means 0. But I need a placeholder for that degree, okay? So I've got 2 degrees, 1 degrees, 0 degrees. So I'm good. I don't have to add anything in. We will do an example where we are missing a term, so you'll see how. Okay, so let's make a little note. There are no missing terms. So this is how you do it, okay? Look at the first term in your divisor. Look at the first term in your dividend. And this is how I think of it. I think of it as x times what will give me 4x squared.
2x.
4x, right? Because 4x times x is 4x squared, okay? So 4x is what I'm going to put up in the quotient, but you need to line everything up. So 4x is a linear term. I'm going to put that above the linear term. Okay? Now just like when I multiplied with regular numbers, now I'm going to multiply. But I've got 2 terms out here in the divisor, so I need to make sure I multiply by both of those terms, and I put like terms under like terms. All right? Everything's got to line up. So what is 4x times x? 4x squared. That first term must be identical. If it's not, then either we pick the wrong number to put up here in the quotient or we multiplied wrong. Okay? Now I have to multiply by the linear term. Or, I'm sorry, by the constant. 4x times positive 5 make 20x, and it's positive, and it's linear, and it goes right below the linear term. Now, above, with numbers, we draw a line, we change the sign. But here's the thing, I've got 2 terms down here, so make sure you don't just change the sign of the first term, you have to change the sign of every term. So I'm drawing a line, and at 4x will become negative 4x squared, and positive 20x will become negative 20x. Notice, I'm using a different color, so I can tell when I go to combine like terms, what sign that I'm using. So make sure in your paper you know what you've got going on, okay? Alright, now you're combining like terms. What's 4x squared minus 4x squared? 0. If these 2 terms don't cancel, something's wrong. They always have to cancel, okay? That's your goal. Try to get them to go away so you can move on to the next one. What's a positive 23x, and we're adding and subtracting now, not multiplying, minus 20x? 3x. Now, just like with regular long division, now I'm just going to bring down the next term. So that minus 16, I will drop it like it's hot. Of the minus 16? No. I will, the next time when I go around and I draw a line and change the sign, because the minus 16 wasn't down on this line yet. Okay, so I didn't change its sign. I will end up changing the sign, but not yet. So now I'll just start the process all over again. But instead of saying, looking at the first term in the divisor and the first term in the dividend, now I'm looking at the first term in the divisor and then what I created down here. Okay? So x times what is 3x? 3. And it's positive. You need a sign. So up here, I'm putting a positive 3. And then I just need to process all over again. Now I've got to multiply. 3 times x is, notice how these terms are identical. They don't cancel, but they will when I draw a line and change the sign. If they're not identical, something's wrong. And then don't forget I've got to multiply the constant. So a positive 3 times a positive 5, positive 15. Draw a line and change the signs, both of them. So this 3x will become negative 3x. This positive 15 will become negative 15. So 3x minus 3x is 0. If it doesn't cancel, you did something wrong. Negative 16 minus 15. Negative what? 31. Is there anything else to bring down? No. So my remainder is negative 31. Is x plus 5 times 4x plus 3, 4x squared plus 28, 3x minus 16? No, they're not factors because I have a remainder. If this remainder is 0, I would know that I could multiply these 2 factors together and they would give me 4x squared plus 23x minus 16. But because my remainder is not 0, I know these are not factors. together, okay? So when you write your answer, you can either write it as 4x plus 3 remainder negative 31, or, just like we did before, you can do 4x plus 3, and then you do your remainder over your divisor. So since your remainder is negative, you usually write minus, and then the fraction, 31 over the divisor, x plus 5. Make myself a little note here. Draw a line and change the signs of every term. We did that here and here. Okay, I'm going to try to get through this next one before the bell rings. Your homework, I'm not going to give you homework over the division. So just those 4 problems I assigned you before will be your homework, okay? And if you're watching this video, I'm just currently talking to my second period right now. This may not apply to you. All right, page 105, we're going to do the same thing. I'm going to go a little bit faster, so I'm going to try to beat that bell. And the next class we'll do a little more work on the division, and also I'm going to give you a review and then test on Friday. If you can be here Friday, please do. It's a lot easier to take the test when it's fresh in your memory than just trying to be absent and making it up a month down the road. My question says, is x squared plus 1 a factor of 3x to the 4th minus 4x cubed plus 12x squared plus 5? It wants to know if it's a factor, okay? We just learned the remainder theorem. If we divide by x squared plus 1 and we get a remainder of 0, then we can say yes, it is a factor, because the remainder theorem tells us so. If we divide and we get a remainder that's any number other than 0, we'll say no, it's not a factor. Because according to the remainder theorem, you have to have a remainder of 0 in order for it to be a factor. Okay? So, my divisor is x squared plus 1. My dividend is 3x to the 4th minus 4x cubed plus 12x squared plus 5.
Don't you have to have it in 0 x?
Yes, good job, Owen. Owen said I'm missing a term, right? Look in the divisor. I have 2 degrees straight to 0 degrees. Can I do that? No, I need to have 2, 1, 0. So in the divisor, I'll put x squared. A linear term, I can just put 0, but I like to put x, 0x. Don't just put x, because you're changing the problem when you add x in. But isn't 0x mean 0 times x, which is the same thing as 0? So it changed the meaning, right? And then don't forget your plus 1. In the dividend, am I missing any terms?
Yes.
Yeah, because I go 4 degrees, 3 degrees, 2 degrees, 0 degrees. So I'm missing a linear term in there as well. So I need to add that in. Sometimes it's the same, like on this one I was missing linear and I'm missing linear, but that's just coincidence, okay? So I have 3x to the 4th minus 4x cubed plus 12x squared. And then here's my linear term, plus 0x. You can do plus or minus, doesn't matter. And then don't forget your plus 5. Now, this is a lot bigger problem, but we do the same thing over and over. It's the same pattern. You just keep repeating until there's nothing else to bring down. Okay? So, look at your first term in the divisor, the first term in the dividend. X squared times what is 3x to the 4th? 3x squared. And it's a quadratic term, so I'm going to put it above the quadratic term. Because once I put this in my quotient, I need to have it lined up with everything. Wherever I start and then everything to the right of, I need to have something above those terms. That also helps me make sure I know something's not wrong. I'm not missing something, I forget something, all that stuff. And this time when I multiply the 3x squared times all three terms in the divisor. And they needed to line up below their like term, okay? Am I going too fast? Okay. If not, you can watch the video again when you get home. So exciting. Alright, what's 3x squared times x squared? 3x to the fourth. Exactly. And of course, again, they're identical. If it's not, something's wrong. What's 3x squared times 0x? 0x cubed, which is technically 0, right? But I'm going to put plus 0x cubed, which that means 0, just to make sure my cubic term lined up with my cubic term. Because 3 times 0 is 0, and x squared times x is x cubed, but really, it's all just a big 0. So if you put a 0 there, that's correct. But okay, now move to the 1. 3x squared times 1? 3x squared, and it's positive, right? For now. But then, so I had 3 terms out here, I have 3 terms over here. These will be ones that I drop down. So I'm going to draw a line and change the sign of all 3 of these terms. So this is a negative, they all become negative. If they start as negative, they'll change to a positive. Because when you subtract something, doesn't it change the sign, right? Alright, 3x to the fourth minus 3x to the fourth, 0. Negative 4x cubed minus 0x cubed. Negative 4x cubed. Positive 12x squared minus 3x squared. And that's positive, right? Okay, now I've subtracted all 3 of these terms. Now just go to my next one, just 1, and we'll bring it down. Start all over again. Now I'm looking at the divisor, and then this new polynomial that I created. X squared times what is negative 4x cubed? Negative 4x, perfect. It's linear, it's lining up above the linear term, we're all good. Multiply negative 4x times x squared. Very good. Negative 4x times 0x. I'll do plus 0x squared. Negative 4x times positive 1. Negative 4x. Draw a line, change the sign. So with these minuses, I'm just going to put a plus through it. So I become positive. Of course, I'm using a different color. This positive will become a negative. And this negative 4x will become a positive 4x. Right, cool? Negative 4x cubed plus 4x cubed is 0. If it's not, something's wrong. Positive 9x squared minus 0x squared is just 9x squared. 0x, now this is a plus 4x, right? Because I changed the sign. So that's plus 4x. Am I finished? Is that my remainder? No. Now I've got one more thing to bring down. So I'm going to have to go through the process again. X squared times what is 9x squared?
9.
Just 9, right? And it's a plus 9. You got to have your signs. 9 times x squared is 9x squared. 9 times 0x is 0, but I'm going to put a 0x. 9 times 1 is positive 9. Draw a line, change the signs of all of them. 9x squared will become negative, 0x will become negative, positive 9 will become negative 9. 9x squared minus 9x squared is 0. Plus 4x minus 0x is 4x. Positive 5 minus 9 is minus 4. Is there anything left to bring down? No, so this is my remainder. So if it asks me for the quotient, my quotient is 3x squared minus 4x plus 9. My remainder, the first term is positive, so I put a plus. And then in the numerator, 4x minus 4. And the divisor, you don't need to put it with that placeholder in. Put it as original x squared plus 1. But the question really didn't ask me what the quotient was. It asked me if x squared plus 1 was a factor. Is it? No. And how do we know that? Because I have a remainder that's something other than 0, right? So to answer my question, I'm going to say no, x squared plus 1 is not a factor because the remainder is not 0. I'm going to put a little star, remainder theorem. And that's division.